Hey everyone, this week's lesson is going to be on the standard form of a linear equation. So last week we learned all about the slope-intercept form. If you remember the slope-intercept form, if I just write it out, it was y is equal to mx plus b. Okay, remember that? So slope-intercept where we have slope and we have the y-intercept. Okay, so that's why it's called the slope-intercept form, right? So now this week I'm introducing to you guys the standard form. So it's just another way to write a linear equation. So in the standard form, we format it as ax plus by is equal to c, okay? Where c is some constant, like a number, okay? X and Y are still our variables, right? Are independent for X and are dependent for Y. And then A and B are called coefficients. Okay, so that's what A and B are called. Okay, and when linear equations are in standard form, we typically want to convert these into slope-intercept form. And this is because once we have our equation in slope-intercept form, it's so much easier to graph. Okay, so what we're going to be doing is we're going to be taking equations that are written in standard form, such as this, and we're going to be converting them or rearranging them to get them into slope-intercept form, because slope-intercept form is the most convenient and the most useful way that we can express an equation. Okay, so let's just go over the brief steps, okay, to convert from standard form to slope-intercept form. So I'm just going to remind you guys, slope-intercept form, it is rearranged and isolated for the variable y, isn't it? Right? It just has y is all alone and everything else is on the other side of the equal sign. Okay, so to convert from standard to slope-intercept, all we have to do is isolate and solve for y. Okay, so we can do that with two easy steps. Step one, right, is to add or subtract, depending on whether the coefficient is positive or negative, add or subtract the term ax to move it to the other side. Right? Because if we're isolating for y, doesn't it make sense that we have to take this term and move it to the other side? Yeah, so that would be our first step, right? Move that ax term to the other side, okay? So once we've done that, we might have something that looks like b times y is equal to minus ax plus c, right? When we rearrange and move that ax over. Well, we still haven't isolated for y, okay? Because we still have that b beside the y. So again, to isolate for y, our second step, right, is simply to divide all terms by b. Divide all terms by the coefficient b, right? B. Okay, because if we divide everything by b, then we are going to end up with only y on the left side of our equation, which is our goal, right? That's the whole point. Okay, so two simple steps and we'll get y all isolated. So let's do that. Okay, so let's do some practice. So the first thing we want to do is we want to rewrite each equation in slope-intercept form. So remember, right, we want to isolate for y. Okay, well, in this case, we don't, our coefficients a and b are simply 1, and our constant is -2, right? So if you're confused looking at this equation, a is 1, b is also 1, and c is -2, right? So that's how it fits on our equation there in standard form. So the first thing we have to do is add or subtract the x term and move it to the other side. So we're going to do that. Y is equal to -x minus 2. Okay? So we would have one more step, except for the fact that y doesn't have a number next to it. So we've already isolated this equation for y. Okay? So now this equation is in slope-intercept form, right? So if you were to graph it, the slope would be -1, and the y-intercept would be -2, okay? And we got that by just rearranging the standard form of the equation, okay? So, I mean, that was a pretty easy one. Let's try example 2. So again, we want to rearrange the standard form, right? Where we have ax plus by is equal to c. And we want to convert it into y equals mx plus b, okay? So again, remember, we're going from ax plus by equals to c, and we want to convert to y equals mx plus b. Okay, so we want to convert it until y is all alone, essentially. All right, so let's get started again. So the first thing I need to do is to isolate y, is to move this term, my x term, to the other side of the equal sign. So when I rearrange, I'm going to get y is equal to +4, so just 4x, plus 5. There we go. So that's slope-intercept form, where we have a slope of 4 and a y-intercept of +5. Okay. Again, that was easy. It was easy because we didn't have any coefficient next to our y. So let's try another example where it gets a little bit more difficult and where we do have a coefficient next to our y term. Okay, so again, we're just isolating for y. We're solving for y. So step 1 is move our x term to the other side. So 6y is equal to -5x plus 12. Okay, so again, we've almost isolated for y, but in this case, we need to move on to step 2, which is to divide all terms by b, okay, where b in this case is 6. So I'm going to do that. I'm going to divide all my terms by 6. Okay, that leaves me with only y, right, because it cancels. And that leaves me with a slope of -5/6x plus, well, this ratio can be simplified, so +2. Okay, so that means the slope-intercept form of the equation is y is equal to -5/6x plus 2, right? So our slope of this line would be -5/6, and our y-intercept would be +2. All right, let's do, let's do some more. Just get used to it. So we're rearranging equations, okay? You can always pause the video and try these on your own and then start the video again and see if you got the answer correct. Obviously, there's options available. So please try on your own first. Okay, so again, step 1, move that x term to the other side. right? Move that x term to the other side. So we have 6y is equal to positive 2x minus 24. Okay, divide each side by 6 now. So I'm going to have y is equal to 2 over 6x minus 24 over 6. That simplifies to 1 over 3x minus 4. Okay, so this is the slope-intercept form of the standard form above. Okay, where we have a slope of 1 over 3, a y-intercept of negative 4. Okay. So I'm going to leave these last two for you. No, I'm going to do, sorry guys, I'm just going to do them. Okay, so here we go. We have first step, isolate for, move the x term over, right? So we have negative 5y is equal to minus 3x plus 5. Okay, now divide both sides by the coefficient of y. So don't divide by 5. You have to divide by negative 5. Negative 5. Negative 5. Okay? And I need to make a note because so many of you guys are making this mistake over and over again. Okay? If you have a fraction where you have negative 3 and over negative 5, if you leave your answer like that, it is wrong. Okay? You have to understand that. You can't have a negative over a negative. When you have two negatives, it becomes positive. Okay? So I don't want to see any more of this. Negative over negative. You guys got to get over it. Okay? So So dividing each term by 5, negative 5, we get 3 over 5x. 5 divided by negative 5 is minus 1. Okay, so there we go. We have our slope-intercept form where our slope is positive 3 over 5 and our y-intercept is at negative 1. Okay, last one. So again, move the x term over. So we have negative 2y is equal to negative x plus 16. And then we have y is equal to negative 1 over negative 2x plus 16 over negative 2. This becomes positive 1/2 minus 8. Okay, so again, all we're doing is we're rearranging and isolating for y. So here we go. We would have a slope of 1 over 2 and a y-intercept of negative 8. Okay, so those 6 questions are to get you guys used to rearranging equations. But I mean, honestly, we've done this before so much that you guys should have no problem with rearranging equations at this point. Okay, so let's get some more practice with graphing. All right, so what we're going to do now is we're going to take standard form equations, right, in the form ax plus by equals c, and we're going to convert them into slope-intercept form, and then from slope-intercept form, we're going to graph it, okay? So let's go for it. So step 1, isolate for y. Get y alone. So it becomes negative 3x plus 5. Okay, all I did was I moved that positive 3x to the other side of the equation. Easy. Okay, so from our equation, our slope is negative 3. And our y-intercept is positive 5. Okay, so we need to remember that y-intercept, that tells us where to put our first point. right? Our first point will go at 0, comma, positive 5, okay? So let's remember how to do that. Right here. So we're going to take a marker or put our pen down and put our y-intercept in. Okay, so positive 5. Now we're going to use our slope to get the next points. Okay, so remember, slope is rise over run, right? So rise over run. So if we have just -3, remember that it's -3 over 1. Okay, so what this means is down 3 over 1. Okay, so let's make sure we're doing it right. Okay, so down 3 over 1. So that's where I'm going to put my second point. Okay, I'm going to do it again. So I'm going to go down 3. So 1, 2, 3 over 1. Oops. Okay, and then it's freezing. Okay, and then put my points right in there. Okay, I could keep going, right? Down 3 over 1 would bring me here. Okay, so you just continue the pattern until you have enough points, right? And then you're going to get your ruler out and connect the points, connect the lines, I suppose. I'm just going to get rid of this because technically they shouldn't be showing up on your graph, right? It should just be the orange dots. Okay, so connect the points. Connect the points. Add my arrow ends, right? Like that, and we're good. All right, so there we go. So we took a standard form, we converted it into slope-intercept form, and then we use that information to create a graph. Okay, let's try a couple more, why don't we? So again, convert this into slope-intercept form and then graph it. So what we have to do first is isolate for y. We're going to bring this term over. So y is equal to positive 2x minus 1. Okay, that was an easy rearranging, okay? So that gives us an m equal to 2, which is really 2 over 1, and a y-intercept of -1, which means our first point goes at 0, -1. Okay? And remember, our slope is rise over run. So rise 2 over 1. Okay, so let's use that information to graph. So again, we start with our y-intercept. There we go. Put your point down on your y-intercept. Then use the slope to get the rest of your points. Okay? So, just give me a second here. Ugh. Oh, whatever. Okay, so rise 2 over 1. So we're going to rise 2 and we're going to move over 1. And that tells me where to put my next point. Okay, I'm going to do it again. I'm going to go rise 2 over 1. And I'm going to put my next point. Remember, you can go backwards too. So instead of going up 1 over 1, we can go, instead of going up 2 over 1, we can go down 2 and then back 1, right? Which is the opposite. So as long as all of our points line up, we're good. And then my computer wants to wake up and work. There we go. And connect the points. Okay, add your arrow ends, and you're done. Okay, So there you go. So again, what we did is we took standard form, we converted into slope-intercept form, and then we used the information to graph it. Okay, let's do it one more time. Why not? Okay, so question 10. 5x plus 2y is equal to 6. Okay, so let's isolate for y. So step 1 is move the 5x to the other side. Okay, that leaves us with 2y is equal to negative 5x plus 6. Next step is to divide everything by 2. So every single term needs to be divided by 2. So 2y divided by 2 is just y. When I divide this term by 2, it's negative 5 over 2x. And when I divide 6 by 2, it's 3. Okay, so my m, my slope, is negative 5 over 2. My b is positive 3. Okay, so again, I use this information to graph. So what I start with is I start with my y-intercept. That tells me my first point. So let's go ahead and put my first point down, 0, 3. Okay, now we're going to use my slope to find the next points. So again, it says down 5, right, because it's negative, down 5 over 2. So down 5 over 2. That's where my next point goes. Okay, and I repeat it, down 5 over 2, but that takes me off the screen. So that's all the points I'm allowed to make here. Connect the line. Oops. And there we go. Right, so you start with your y-intercept and you use the slope to get the next points. Okay, let's do the next one. So again, let's convert it to slope-intercept form. So we're going to bring this one over, and we get 2y is equal to negative x minus 6. And then we're going to divide each term by 2, so we're going to get negative 1 over 2x minus 3. Right, we divided each term by 2. So my slope is going to be negative 1 over 2, and my b is going to be negative 3. Okay, so I start with my y-intercept. Put my first point down. Okay, now I use my slope to get my next points. So this means down 1 over 2. Down 1 over 2. So down 1 over 2. Do it again. Down 1 over 2. Okay, go backwards. Up 1, back 2. Do it again. Up 1, back 2, right? So you end up with a bunch of points on the line. And once you have enough to get your ruler out, connect the points. Extend your line through the whole graph, and we're good. Okay. Here we go. All right. Let's do a few more. Let's do 12, and then I'm going to leave the rest for you guys to do. Okay. So again, we're going to isolate for y. So we have negative y is equal to negative x plus 5. Now we're going to divide everything by negative 1. So we're going to have y is equal to positive x minus 5. All right. So that means our slope is 1, which means 1 over 1. Okay, rise 1, run 1. And our y-intercept is negative 5. So that's the point 0, comma, negative 5. So put your y-intercept down and use your slope. Okay, a slope of 1 is the easiest. The slope of 1 is the easiest. Rise 1 over 1, right? Rise 1 over run. It's pretty easy, just like that. There we go. All right, so I'll leave those last two for you guys to try on your own. I think this video is long enough already. And I'll post the answers to the last two so that you guys can check them out on your own. Okay, great.